Welcome to the Stray Pointers podcast, where seemingly ordinary people join us for extraordinary discussions. You're watching Season 3, Episode 9 of the Stray Pointers podcast. This episode was recorded on September 6th, 2025. I'm your host, Jim Lawless. For more information about the show, including the show notes for this episode, please visit straypointers.com. Joining the show today is telecommunications and 8-bit computing pioneer Nick Andrew. Nick, welcome to the show.
Thanks, Jim. Glad to be here.
Good to have you. So, Nick, your name came up in some of the TRS-80 forums, and so I did a little Googling and a little digging, and what I found was that you have quite a history with a TRS-80 Model I workalike called the Dick Smith System-80, including running a bulletin board system called the Zeta BBS. So what I'd kind of like to do is talk with you a little bit and find out a little bit about your background and how you came to acquire and learn to program a Dick Smith System-80 computer.
Yeah, sure. So I was interested in computers from a very young age. My uncle was a lecturer at Deakin University in Victoria, and he sort of set me down the path of interest in computers specifically. But he was a big science fanatic, and so science in general. My dad was an engineer. My mum was a chemist, and my mum's side of the family was, in fact, all educators.
Okay. So math and science was in your blood.
It was a family that promoted education, and my particular obsession from about age 14, I guess, was computing. So I finally managed to convince my parents to buy me a computer at around about that age, and started simple, as we all do, and went from there.
So the System-80, that was a workalike for the TRS-80 Model I. Was there a reason that you aligned with that computer instead of other computers on the market?
Yes, it was cheap, so my parents could afford it, and we had a local dealer. So it was the System-80 was designed in Hong Kong for Dick Smith computers as a work-like, as you said. Some minor internal differences, just enough to make it look like it was an actual computer itself, as opposed to simply copying Tandy's product. And Dick Smith was a very popular Australian electronics retailer.
Okay. Now, did this run?
If you want to do another episode, you should interview Dick Smith and talk about his history, because it's quite spectacular.
I'll do that. I'll try to do that. How hard could it be to find some guy named Dick Smith on the internet, right? So could the System-80 run most off-the-shelf TRS-80 Model I software?
Yeah, largely. There were a few minor differences, like accessing the printer and the double width video, but it could run most of the off-the-shelf software.
Now, in some emails that you and I exchanged, you said you had the computer and you learned BASIC, and you experimented with BASIC for about a month and then went right to assembly language. Was there a community that sort of led you to know that this was the next step?
No, I think I just bought some books. I noticed you had the cover of TRS-80 Assembly Language Programming on your blog, on your website.
Mm-hmm.
And I went to look for my own copy of that, but I'm afraid it's been lost over the years. That was the book I used extensively, and it I started out similar to you in that I didn't understand the difference between machine language instructions and pseudo-ops.
Oh, sure.
So I spent some time trying to understand how to assemble the org statement. I didn't have an assembler, so the first few fumbling assembly language programs I wrote, I assembled them by hand. But eventually I cracked the mystery of pseudo-ops and went on from there. And
Okay.
it was an efficiency thing. BASIC ran extremely slowly on the system, and if you wanted to get both speed and some space back, then you needed to go assembler.
Okay. Were there were there communities that supported the System 80 in your area, or magazines or anything like that?
Um, I don't really recall. I think there might have been some magazines, but I didn't buy them. I didn't have any money, so largely no.
Did you have friends that had a System 80?
When I wrote my BBS, I was in uni, and I had some friends who had one had a System-80, one had a TRS-80 Model I, and a Model 4.
Oh, wow. Okay. Okay. So you you had an interest in computers. You also had an interest in electronics, yes?
Yeah, yeah. So I started with simple electronics when I was in high school. I would do things like I remember building a kit for the chemistry teacher. It emitted high frequency sound to scare off mosquitoes,
Oh,
and I remember fixing a television for one of the other kids in school.
so then at some point you decided to couple your electronics experiments to your System 80. Do you remember what that first gizmo was that you connected?
Yes, I bought my first modem in 1984, based on my friend with the two computers who had already bought a modem. And we would call each other up at night and type on our various terminal programs. And the challenge that we set ourselves was the we would give the other person access to a debugger or something. We try and lock down our system so it wasn't possible to get outside the terminal program. And then we would watch as the other person attempted to hack our computer and get into it. It was quite a lot of fun. The electronic uh, beam of light over my head came when there was a project in one of the magazines for a a telephone ring detect. Basically, you attach it illegally to the telephone lines,
Hmm.
and it would flash an LED when the telephone was ringing. And I reasoned that if I had a circuit that uh, could light an LED, then it could also drive an optocoupler, and I could use the signal from the optocoupler to tell for the computer to tell if the telephone was ringing. Now, I should preface this by saying that the modem I bought in 1984 was didn't have auto answer, didn't have auto dial, so it was a pretty manual affair, and I couldn't afford an expensive modem that could do these things. And indeed, in those days, I don't think the Hayes protocol had even been invented.
Hmm.
So it was it was just um, a a flash of light for me to realize that I could set these things up, and then I could have the computer control whether or not the modem answered the phone. If I
Okay.
could do that, then I could accept an incoming telephone call from a user.
Okay, so that was your first hardware interface to your System 80 was the auto
Oh no,
answer circuit.
wasn't the first one. No, that was a
Okay,
few. I did a few before that.
What was the first one where you felt brave enough to try and experiment with your expensive computer and a dollar's worth of electronics parts?
Probably the memory upgrade. One of the
Oh,
so the System-80s came with 16K of
hmm.
RAM inbuilt, and there was a fairly cheap memory upgrade to 48K, which was the maximum that the system could normally handle, done by piggybacking the RAM chips on top of the existing RAM chips. So I forget the RAM chips that they used were 16K times 1 bit wide. And so if you stuck another two chips on top of the first two
Hmm.
chips, you could extend the memory to 48K. With a catch, of course, you can't just stick another RAM chip. You can't just wire all 16 pins directly to the other 16 pins, because then it's just doing the same job. So you had to wire 14 of the pins and then send different signals to two of those pins. So I
Yep.
actually figured this out by reading the schematic for the System-80. Fortunately, the system was well documented by Dick Smith, and some experimenting, and eventually managed to improve the memory footprint.
Okay. Okay. So you're at university and you are exchanging you're playing hacker games with your friend over the phone in the evenings. When did you decide that you wanted to extend that to make a full-blown bulletin board system?
Yeah, so that was where the LED thing came in. Uh, in 1984, it was when I was playing hacker games with my friend. We would also dial the local bulletin boards. There were a few of them around, and uh, some of them were TRS-80 based, right? And I don't think the IBM PC was even a thing by then. But uh, the the system operators, the sysops, they were sort of the elite of the community. They were the people who ran the systems, sometimes big systems for the day. And uh, I, when I realized that such a thing might be within my technical capability, uh, I wanted to be one.
Okay, so did this require sacrificing your only machine, as many
Yes,
people did?
unfortunately. I don't know how I managed all that, given all the other stuff that I was doing on the TRS-80.
Okay,
I
so
did buy a second TRS-80 at some point, but I never really used it extensively because I'd made a lot of hardware changes to my existing System-80. And yeah, it was nervous sometimes realizing that if I stuffed up this change, uh, I was left with zero computers. So it wasn't just the memory upgrade, but I also did a real time clock thing. I did a RS-232 interface. My uncle's friend had built one down in Victoria and um sent one along to me. Lowercase modification. The 48K RAM upgrade. Uh, Pretty much by the time I was finished first year university, became a 256K RAM upgrade, and we might talk about that later. I'd extended the keyboard so I could move the keyboard physically away from the computer. The the System-80 had a nicer looking case than the TRS-80. The TRS-80 was grey and plasticky. The
mhm.
System-80 had a sort of a wood, fake wood panel thing, looking like a cross from a Heathkit computer in the 70s, I think.
Yep, I'm going to share one of your pictures here. This is a picture that I had snapshotted from your hardware section on your website. So this is what a System 80 looks like, and this is what you're talking about, where the cassette and keyboard and entire computer were built into one unit.
Yeah, so you can see there I've added some extra keys at the top of the keyboard. There's a sort of D-shaped hole there, which is where I put the keyboard extension. Um, the the photo was taken around about the year 2001, so it would have been 21 years old at that time, give or take. And you can see the yellowing of the formerly cream-colored plastic due to the effect of sunlight and poor plastic composition. So the original color of the computer was more or less the color of the expansion unit on the top left there.
Okay. Now, did you
Nice
ever have
creamy color.
did you ever have people asking you if they could have copies of the BBS code and you had to kind of shy them away because you had such a unique hardware setup?
I don't think I did really. Um, Most of the users of the BBS were just happy to use the BBS, and of course I wrote all the code for that. Uh, People who had more less modified machines and more money than me could have bought uh, actual BBS software because the biggest BBS that was running in Sydney at the time for TRS-80s at least was the system operator was not the programmer. The programmer would also supply copies of his BBS to others. In fact, it was also running in Perth at the time, if I recall.
Okay. Did your BBS outshine any of these others with all the technical mods that you made?
Probably in a couple of ways. So the BBS BBSs in general had two things, right? They had electronic messaging and they had sort of group messages. And mine in particular, my innovation for the group messaging was uh, to have a hierarchy of categories as opposed to having a simple flat structure. And so that's what I wrote, and I called it the tree board. And in fact, I actually sold a copy of the tree board for NPM 86 to the disadvantaged schools department in New South Wales
Was
because
that
they had seen the BBS in use and they had a mini computer to run it, NPM 86, a multi-user version of CPM, and I ported my treeboard code to NPM 86 on almost a line-by-line basis.
you, from Z80 assembly
From
to 80?
Zeta-80 assembly to 8086 assembly.
Okay. Wow. That's no small task.
Yeah.
Okay. Let's talk a little bit more about your 256K extension and what did you use that for on
That was
in the
fun.
board software?
So that was the thing that basically enabled a fairly underpowered System-80 to run some decent bulletin board software. So how did it work? Because the Z80 itself can only address 64 kilobytes of RAM. It's a 8-bit processor with 16-bit address bus. So it became possible when slightly larger memory chips became available, and I organized it as a paged memory system. So memory was divided up into 1K pages, and there was a fast lookup table. It was basically a memory chip that went between the CPU and the memory to remap the 64 kilobytes of Z80 addressable space into the actual 256 kilobytes of available memory.
Okay. And at one time you had modified applications like the original Zork 1 to actually run on your BBS, yes?
Yeah. So the paged memory allowed me to load up and run a program, and when the program was done, to page back in the memory from the program that was running before it. At this time, I was in university. I'd been introduced to Unix. I became a big Unix fanatic, and so I wanted to have some of the same capabilities available on my machine. And one of those things was that you could run a program from another program, and when the other program finished, return back to the first program.
Okay.
And yeah, I used it to make Zork available on my BBS, and that was fun. So some of my friends from the university days, they were big Infocom fanatics, and they reverse engineered the so-called Z machine that runs Infocom games,
Mm-hmm.
and they produced their own Infocom executors for the TRS-80 for the IBM PC and possibly some others. I can't remember what they called themselves, but basically, I think they knew as much about Infocom games as anybody other than Infocom themselves.
Wow.
I
Okay.
didn't actually use their executor to run my thing because I sort of done a bit of reverse engineering on Zork myself, but I certainly got some good tips from them.
Very good. So, did you ever move beyond assembly language into something like C for the board software?
Yeah, I tried to incorporate C whenever possible into the BBS simply for programming efficiency, really. It was quicker to write C code. But the C that was available at the time was very primitive. The Z80 is not a processor well designed for running C code anyway. So it was a work in progress. Some programs were mixtures of C and assembler code.
Okay. Now, you had said on in an email exchange that we had that when you were at university, you were exposed to Unix and networking, that you had been on a network in Australia called ACS-NET, which provided Usenet news and email gateways to UUCP nodes and things like that, and some file transfer capability. Did this influence the next direction of your BBS software?
Very much because I was enamored with networking, and and ACS.NET was the closest that Australia had to the internet. The transition. ACS.NET was a store and forward network, but you didn't really notice the difference for email and Usenet News, which were the two main use cases at the time. And so what I actually did. Because the predominant bulletin board networking software at the time was FidoNet, I
Mm-hmm.
actually attended uh, one of the earliest meetings, if not the earliest meeting, establishing a FidoNet network in Australia. And I petitioned them to let me join the network, even though I didn't run the actual FidoNet software because FidoNet was MS-DOS based,
Mm-hmm.
uh, and I obviously wasn't. And because the protocol was documented, I figured I can just implement the protocol. It doesn't look too hard. And amazingly, they accepted, and so I became a FidoNet node, and my users could then send and receive FidoNet messages.
Okay. Now, here's just a bit of local trivia for you. There was a gent that ran a bulletin board system here in the Omaha, Nebraska area that had built a FidoNet interface for his CPM-based BBS, and it was a
Nice.
64K Z80 based one. And I think it ran without any memory extensions or anything like that. And the first time he had some kind of an issue was when they moved from processing some of the compressed volumes of however they would move the data from System Enhancement Associates ARC to PKware's zip, and his system didn't have an unzip program on it, so he had to had to deal with that. But I think the two of you probably somewhere around the same time both interfaced Z80 systems to FidoNet.
Yeah, yeah. As far as I know, I'm the only System-80 or TRS-80 that joined the FidoNet, and yes, I do recall having the same kind of issues because there were no compression programs for the TRS-80, and so I think I might have ported an ARC from the IBM PC. I'm not
Mm-hmm.
entirely sure.
Mm-hmm.
But yeah, it was a bit of uh, fiddling and building up things from a patchwork to to enable full FidoNet operation.
Okay. Now you took that a step further into ACSNet at some point, did you not?
Yeah, so when I was in uni, my third year was an industrial year, and the optional you could pick various what's the word? You could basically choose the courses that you wanted to do, and so I chose to do a project, and the university approved me to link the ACSNet with the FidoNet in a system that I called Fido Gate. And so my hidden agenda here was to enable uh, internet email use for myself and my users, but particularly myself after I left university, because at the time people would have uh, internet, such as it was, access only until they left university, and then they would join the real world, which of course was not an internet world back in the late 80s. And I didn't want to give up that capability.
Okay, so your users then all of a sudden had the ability to send internet mail and receive internet
Yeah,
mail?
yeah.
And
The internet mail, ACSNet mail used domain names like proper internet mail nowadays,
mhm.
and I had the support of the systems administrator at my university, and we talked about protocols, and they had a modem there interfacing to the main Unix system that was on ACSNet.
Mhm.
We worked together to set up things like the conversion software. So there was a Unix part of the software which would be run somehow when I dialed in from my modem, and there was obviously my Z80 code, mixture of Z80 and C, running on the TRS-80 to do the conversions.
Okay, now you had Usenet News access as well, correct?
Yeah, Usenet News. So the hierarchical BBS chat system was based on the thing that I'd seen in Usenet News, which is of course news group hierarchies. And so I would pick small numbers of those groups and put them on the BBS.
Okay. Now even small numbers of the Usenet groups might be pretty chatty. So you're carrying some FidoNet nodes, you're doing email and Usenet via UUCP. What are you using for disk storage at this time? And how much did you
Uh,
have?
I never managed to interface a hard drive to my System-80, so I had three disk drives. Each of them were 80-track double-sided, double density. By this
Wow.
time, I tried to build my own double density modification and failed. And so after a while, I bought a double density PCB from one of the local TRS-80 hackers here,
Okay.
who's very skilled in electronics. I should say that by the time the uh, the FidoGate stuff was around, I wasn't simply using the TRS-80. I bought myself a 286 based PC clone. I
Mm-hmm.
never ran DOS on it, so it was Minix at the time.
Oh,
So I
sure.
could write more things in C, and
Mm-hmm.
things functionality gradually migrated from the System-80 to Minix. And within a year or two after that, I had bought a Sun workstation. It was a Sun 350, low end, but more capable than either of the two computers before it. And so the BBS functionality gradually grew into being an internet provider through these hardware migrations. I also bought a Sun 360, and that was more capable than the 350, and so on.
So you were you one of the first ISPs in your area then?
Yes, in fact, I came onto the scene just at the point where internet access had gone from a very small number of companies who had deals with universities uh, to provide that to sort of downstream ISPs such as myself. Uh, at around about when was it? Around 92 or 93, I think, was just about the point at which the internet was opened up from an educational, military only network to allowing full commercial access.
Mm-hmm.
And so one of my competitors, as it were, at the time was called APANA. It stands for Australian Public Access Network Association. And so that was an association of BBSs, so we say,
Mm-hmm.
that had had a relationship with one of these commercial organizations to provide them with some internet access. And I think the APANA network did a bit of store and forward themselves, or they use the SOX protocol to talk to upstream
Okay.
systems that were more powerful. And so my BBS, when I decided to go and become an internet provider, then I started to charge for access, and so I used that to springboard into running a commercial operation from it.
Were you were you working at a regular day job at that time?
Yeah, yeah. Worked for IBM in Australia.
Oh, okay.
Yeah.
And so you'd code all day and then go home and code some more?
With the small amount of time that was available to me, yes. Uh, this is a time before IBM as a corporation had discovered the internet. And
Mm-hmm.
so what I was doing was I was going around telling all of the management in my organization about the internet.
Mm-hmm.
And some of them were quite receptive, and some of them just didn't want to know.
Wow.
This
Wow.
is before the IBM Global Network. So this
Sure.
is maybe 18 months, 2 years before IBM as a corporation discovered the internet and decided that they could uh, be a big player by making what they call the IBM Global Network.
Mm-hmm. Did this continue on for a while? Did you keep working at IBM and running your side business?
After around about 1994, 1995, the amount of money I was making from the side business made my IBM salary look silly. So I left IBM, just ran it full time.
Okay. Okay. How long did that business run then, your ISP?
Until 2000, I sold it to Pacific Internet in early 2000, just before the dot-com crash. And then I went and worked for Pacific Internet for a year and a bit. I was their billing systems manager in, first of all, Sydney, and then head office in South Bank in Victoria.
Mm-hmm.
Left Pacific Internet, became a man of leisure for the next 6 months or so until the money started to run out.
Mm-hmm.
And in early 2002, I was contacted by an old friend of mine, Michael Malone, who was one of the co-founders of Michael said he had a a job requiring somebody with some billing systems experience. And at that point, the billing system was a sort of a key interest of mine. So I was happy to help out there. Michael said he had about 6 months worth of work for me, and that turned into 12 and a half years.
Wow.
Yeah.
So that was an estimate then.
Yes, he had severely underestimated the amount of work required on the billing system. I did a lot of stuff at IONET. I worked on acquisition projects, went and visited quite a few ISPs that IONET acquired. I dug into their billing systems. I converted their customer bases to IONET's internal billing system. I extended IONET's internal billing system so that it was able to essentially represent itself as being the different plans and so on of these other ISPs. So basically helped the acquisition process along. I worked on about 20 acquisitions for IONET over the years.
Okay. You still work in tech today?
Still do, yeah, working for Google in Australia.
Oh, very good. Very good. So are you, do you have any interest, or maybe you have already done it, in putting the Zeta BBS on the internet as a telnetable BBS?
So, so the fun thing is I've always been interested in data preservation. And when I packed up my System-80, I carefully wrapped up all of the diskettes for some undefined future time. And a few years later, I was able to read those diskettes under Linux. And so I copied all the data off and I started to put it into source code control. At the time, TRS-80, there was no source code control.
Sure.
Unix had it, had SCCS, and after that had RCS, and after RCS became CVS, and after CVS became SVN. I have gone through all of these migrations, preserving my original programs from the 1980s, and all the source code is available on GitHub under my username, which is just Nick Andrew, as one word.
Yep.
And the BBS code is there. It may not run without some extensive work because when you run a BBS, it's all about waiting for a call to come in on the modem, accepting the call, getting the user to log in, and then running some programs. So there's stuff in memory basically that's persistent across calls. Some BBSs would reboot after every caller hung up, so the BBS came up with a fresh state. I was not a believer in that mode of operation. My BBS was intended to run and keep on running. So if you want to run the BBS code, you're welcome to it. But you'll need to do a bit of preliminary work and some understanding of the architecture before you can get it going. And on a modern system, which you're probably running a Z80 emulator anyway, that would be doable. The business of the 256 kilobyte RAM expansion is something that you can easily work around in software.
Okay. Do you participate in System-80 projects or TRS-80 projects currently?
Still do, unfortunately. I've preserved all of my old code from the 1980s, and I did a project to try and make sure that code was actually usable, which means that it can be assembled. And so I have a build system that actually goes through the code every hour, tries to assemble it when it's C code, compiles it, makes the binaries. It doesn't run the binaries yet, but I have done some testing, and I know that the binaries work on an actual emulator. And I found through some of the hacking that I've done that I need to actually write some new code. So some new small bits of Z80 assembler are in my repository. And because I now have a proper C compiler that will generate decent Z80 code, then the C programs have been converted where necessary to use the C compiler. And I've written things like a disk.io library, a DOS interface library, so you can easily issue the DOS calls from C programs. And so in some small ways, there is some new TRS-80 development happening.
Are you using a C cross compiler for those, or are they hosted on the machine?
It's SDCC, the
Okay.
small device C compiler with a couple of flags. I'm also using ZMac, the macro assembler. So I needed to make some changes to my original assembler source code so that they would assemble on modern kit. I originally wanted to do all this building on the emulator and verify it using period software. But I just found the existing editor assemblers were too buggy to do that.
Sure.
Programs, if the code was a bit too long, that would just crash at random, and that's not nice. So
Sure.
the goal now is to be able to assemble and or compile the code on modern software using modern language constructs or standards based. At the
Okay.
time, in the late 80s, early 90s, the standards were still quite primitive, and so things like that have been addressed.
So I have to ask, I saw from there's an annual meeting of TRS-80 enthusiasts in America called Tandy Assembly. And I had seen a presentation there from a gentleman who demonstrated some C libraries for SDCC working with the TRS-80. Did that happen to be you?
No, that was not me. I
Okay.
hadn't heard of it.
Okay. I'll have to go back and see who that was.
Yeah, I tried a few different things before landing on SDCC, and there was a bit of work required to have it produce runnable CMD files
Okay.
without too much mucking around.
Oh, this is how we actually got into touch was I had written up a blog post about the structure of those CMD files, and you had emailed me to let me know that you had some more information on those. And that's when I did a little bit of Googling and found out there was more to the story here, more to the Nick Andrews story than just a guy like me noodling around with CMD files.
Yeah. So what happened was I needed to parse CMD files, I think, or I needed to create CMD files. And I write most code in Python nowadays, so it was Python code to do that. And you can find it on my GitHub. And to do that, I wanted an actual specification of what was in a CMD file. So I went and searched online, and there are some descriptions around the place, like on Ira Goldklang's TRS-80.com. There's a description of CMD files, and there's one on your website as well. And I looked at them, and from memory, I knew that they were all incomplete in some respect and incorrect in others. So after a while, I then dug into the operating system, disassembly, new DOS 80 I was using at the time. Surprisingly clever bit of software for the 1980s. And I saw exactly the code it was running to load CMD files. Believe it or not, I had the tab open on my browser for several months, and sorry about that.
No problem.
Believe it or not, I had the tab open on my browser for several months, and I wanted, with your website on it, I wanted to close the tab. So I thought, I'll just shoot him an email with the correction here, and then I can close the tab. And that was it.
Fair enough. I'll have to update that post.
Yeah.
Well, Nick, is there any any message you want to send out to TRS-80 hobbyists, old or new?
Well, it's amazing that people are still interested in this stuff even after some 40 years. So if the TRS-80 was a system that was small enough that you could understand the whole thing if you simply dug into it.
Mm-hmm.
And that, I think, is a skill that we've lost to history because we've, in the 40 years subsequently, stacked protocol on top of protocol and hardware on top of hardware, and obscured the raw facilities of the CPU
Mm-hmm.
and the engineering required to make these things work. So if Z80 programming is your thing, then stick with it because it's a useful skill for other dimensions. Not as powerful or as exciting as the 64-bit Intel processor, but it's something that is simple enough that as a 14, 15-year-old high school student, you can understand it in depth. And so I would certainly recommend it for younger people as well.
Very good. Well, Nick, thank you for your time. This has been a great deal of fun for me.
Yes, it's been a nice trip down memory lane.
Have a good one.
Thank you. Nice to be here.
Thank you all for watching today's show. Let's do this again soon. Take care.